My name is Joe Fieser of Logical Advantage. I've been here about 1.5 years now, and today we're going to do a presentation on Git, GitHub, what is Git, and different usage and tricks of using Git and GitHub to simplify your life. So what is Git? Git is a free open source distributed source control system, and what's important about a distributed source control system compared to a connected source control system is you do not have to be connected to the internet in order to do check-ins. So you literally can pull your repository down your local machine, get on an airplane, perform 50 check-ins, land in another city, push it all up to this system, and it would actually will replay the history of what you've checked in while you're from when you're offline. Git is super blazing fast. Check-ins are virtually instantaneous. Pushing to master, which is the source of where most people are going to store their code, is instantaneous compared to Git and TFS. I mean, compared to TFS and SVN. The nice thing about Git is every single developer on the team can actually have a different workflow for how they actually produce their code, and as long as they push it all to the same master origin, it doesn't really matter. So some people like to create a branch, write their code for the day in a branch, and only after it's been validated and you've pulled latest from the rest of the team do you actually merge it in before you push it to source. And everybody can follow their own pattern for that. I'm actually using Git to TFS provider on a project I'm on right now at work, so I can work with TFS offline, do all my check-ins, pull stuff down, and never affect the team. So if I'm doing something that's breaking change, you can do a breaking change. Stay off, stay away from everybody else. Still do your check-ins and not have to do the whole thing where, well, I can't check in for the next 1.5 days because I might break the build. So why is it better? Everybody that's used SVN knows how painful it is to do merging and branching. Merging and branching in Git is a no-brainer. When it comes to branching is pretty much free. When it comes to space, all branching is in Git is a pointer to a parent or parents, depending if you're doing a merge. Merging, everybody's had the problem with merging. You change one line, you change white space on one line of code in SVN. You try to do a merge, and it tells you have 7,000 merge conflicts in your file. Git is smart enough to realize that those white space characters are not really merge conflicts, and it's also really good at determining that you are the only person that's ever changed that line of code, so there's no point of telling you there's a merge conflict, so it'll just merge the code for you. You still can get merge conflicts in Git, and I'll go through that later and show you how you can actually work around that. Git is open source, so if you're bored out of your mind and you want to contribute to Git because you're a C developer and you have nothing better to do, you can go and do that. Even Microsoft has admitted that there's such a huge developer community around Git that even Microsoft is adding Git support to TFS. You will actually be able to use TFS as a source code provider and actually use Git as the actual method that you actually store your code in. Again, there's a lot better workflows for Git than there is for any other source control system, and when you start getting involved in storing all your code in Git, you'll realize just how small the repository really is compared to how much code you really have. You would think, considering you have every single change that's ever happened anywhere in the project since the beginning of time, this would just be this massive database, and it's not. Git is more in the line of Bazaar and HG Mercurial, so it's an offline provider. You pull your code down, you make your changes, and then you push to an origin, where it does not fit the same model as like an SVN or TFS, or if anybody is still using any of the old Microsoft tools like SourceSafe. Those tools, you have to be online in order to make a change. You've done the thing where you open a project and all of a sudden all your CS proj files have been checked out with no changes because Visual Studio just decided now's a good time to check your files out with no changes. Well, since Git is actually based on differences and not this concept of checking files out for committing, you'll never see that file has ever been checked out unless it legitimately makes a change. So the differences with local versus remote, the thing that people get caught up on with Git is they think, oh, I've checked in the code into Git, everybody else has it. Why is it not on the server and they can't figure out why it's not there? It's because it's only on your local copy. So if you're one of those people that don't push your source to master every couple days, and you're one of those people that has hard drives that die a lot, you can still lose your code because you have to. Oh, hey Dan. You have to actually push your code to, and I think you got stuck in this one.
Learned that the hard way.
You're like, I don't understand. I checked this in a day ago. It's not there. It's because you didn't push it to origin. But what it also means is you literally have every single check-in and every single diff that's ever occurred in the project. Everybody has a copy. So, worst case scenario, the building were to burst into flames. In theory, somebody has the latest copy or multiple people have the latest copy. And you actually can, with multiple people in the same room, it's not easy and it's all command line, but you can actually push and pull between other people on laptops, on local machines, push and pull between each other without ever going back to the master. And you cannot do that with Mercurial easily. So again, you must push your code to an origin or multiple origins. There's no limit where HG has a rule where you can only have one origin that everything must be pushed to. Git, you can push it here, push it over there. It literally, in Git's world, a check-in is really an atomic change to a set of files that just happened at a period of time. It doesn't care where they came from, doesn't care where you put them. And we'll go over that. So the first thing you're going to learn is you're going to go to GitHub and you're going to be like, what is a fork? And it's different than the forks we're using for lunch today. What a fork is, and it's also referred to as a clone. So forks and clones in Git are really the same thing. A fork or a clone is a pointer to the originating source code, either a master or in an open source world, it's whoever originally created the project. A clone and a fork actually is an exact copy of that repository at that moment in time. So, you get on GitHub and these people seem to have this obsession with forking the project and making no change so they can say, look, I have a copy. And, so they're, in the case of the framework that I'm using for this presentation, there's 4,999 stars and 1,600 forks. This project actually has more forks than the Linux kernel. And there's only 12 people that have made changes. So you're sitting there and you're like, wow, this must be, no, there's only 12 people that actually did anything.
So why are you forking it so much?
I think people have this obsession saying, look, I'm involved in open source. And they're not. I don't know. If I fork something, I don't make a change, I kill it. I don't need to hold repositories in my GitHub account just because I need a number. But what's really cool, especially in the GitHub world, is when you make a fork of a project, it really helps when you start working with what they call the network map. And the network map is what shows how everybody in every single fork of the repository is interacting with each other. And I'll show you that in a little bit. So you don't want to just, and you can do this, you don't want to just clone the repository from the source and then just push it up to your own repo on GitHub because you're going to lose that marker that you were a fork. And there is a fix for that. If you do it, you can actually email support and they will make it a fork for you. I'm going to go through some of the Git setup that seems a little lengthy when it comes to setting up things the first time, but unless you plan on using Git once and you just want to see how it works, you really should go through these extra steps because it's going to save you a lot of time later when you start doing real projects on GitHub. So pretty much you need two tools unless you are a command line person and you have nothing better to do but to learn 7,000 switches. You need Git itself, which is at git-svm.com/downloads. And then the IDE in the Windows world that works the best, that most people can figure out, is Git Extensions. And that is one of the few projects left on Google Code. So install Git first, and then install Git Extensions, because once you install Git, you will not need any of the tools that come with Git Extensions. You can install Git Extensions, and it will install about 3 versions behind of Git, and it will work if you just, that's all you can get. But I highly recommend keeping up to date. So I'm going to go through, and all these commands can actually be done from the command line. So I'm going to show you the easy way to set up Git. Every single thing I'm showing you here actually behind the scenes gets mapped to a command line of Git, of configuring it. So the first thing you do is you load up Git Extensions, and for whatever reason you choose the British flag for English. If you want to choose a different language, you can. I think there's like 9 different languages that it supports. And mine has been configured correctly, so everything is green, but most of the time what's going to happen is these two here, but what this is saying is the username has not been configured and there has not been a merge tool set up. So what will happen is there's going to be an icon next to every single thing that needs to be repaired, and what's nice is you just click on it, it'll take you to the correct tab inside the tool. You go and fix it, you'll come back to the checklist tab, you'll hit this save and rescan until this thing finally turns green. So this would be the first screen you're going to end up going to, and this is where you're going to set up your username and your user email. What's interesting about this is even though all these projects people use that are legitimate email address for in GitHub, I never get spam. Like you would think, I mean, my email address is everywhere in GitHub because every single check-in has my email address, and I never get spam. So you can go and set up an alias account if you're worried about it, but everybody remembers you eventually by your email address. So once you get involved in the community, you want to choose an email address that people you want to be associated to. So think about that up front. The username is just a user-friendly name that shows up in the actual committer column inside the IDE. You can put whatever you want, but I use my name. You're going to want to make sure if you're going to use Beyond Compare, you want to make sure that Beyond Compare 3 is installed before you come to the screen. Because if you do and you choose your merge tools Beyond Compare right away, it's automatically going to be able to find it and automatically set up the actual command to be able to call it. If not, you have to go and try to manually set this up later, and it's not fun. I mean, you can always come back to the screen and after you get it installed and and actually do it. Actually, I was on the screen, so I just configured these tools on my machine this morning because I guess for some reason I didn't have them on the metal. And I installed Beyond Compare while on the screen. I actually just selected something off and came back to Beyond Compare 3, and it just magically found it and then configured it, which was kind of hot. This is going to seem weird for people that are only thinking they're ever going to do Windows apps, but for this global default, you're going to want this top checkbox which says check out Windows line style, always check in with Unix command line line feeds. And this can always be changed on a per project basis later, but you might as well just leave this default because every single project you're going to pull down from GitHub that's ever been done with JavaScript or Ruby or anything other than a Windows app is going to be Unix line feeds. And you're going to sit there and you're going to fight Visual Studio with the whole, hey, I got the wrong character in line feed. You want me to fix that for you? And then you're going to save it, and it's going to pick it up as a change, and then you're going to want to check it in, and then you're going to just fight changes that didn't happen. So I highly recommend just leaving it like that, and then on a new project that's Windows only, go and check it. Just, save it as this bottom one, which is check out as is, commit as is, Windows. I always check in with Unix line feeds, even on Windows projects. The second window is the local settings. If by some chance like I said, if you did want to override your username, password, email address, editor merge tool, or the actual settings, this is where you would actually do it. And the reason why it's all blank right now is because I don't have an active project loaded. Once you have an active project loaded, this stuff will fill in if it was configured for this particular project. It gets saved in a file, and I don't know where because I never change it. The next thing you're going to want to have to do, I don't know, is anybody familiar with SSH? So if you do not configure this, and I just found this out this morning also, Git Extensions will still push to GitHub without it, but you're going to have to do an HTTP authentication every single time you do a push or pull. So if that doesn't drive you nuts, you don't have to do these next steps. But once you set up an SSH key on your machine and you configure and you actually load that key once and type in your SSH auth key once, until your machine blue screens or you reboot, you'll never have to type in that username and password again. So it just automatically knows it's authorized, it sends the public key to GitHub, it does the handshaking, and it all just magically works. And it's SSH, in my opinion, it just feels faster than HTTP, maybe because it's less chatty. But inside of Git Extensions, you're going to want to, under remotes, you're going to choose PuTTY, and you're going to say generate or import key, which is the bottom option. This really generic, developer-friendly window is going to pop up, and blank. And the first thing you're going to want to do is you're just going to want to check down click on the generate button. What the generate button is going to do is it's going to want you to sit there and shake your mouse around like you have a nervous condition to create some random data for your public key. right? So you're going to literally sit here and you're going to go like this. You're just going to keep shaking the mouse back and forth until it finally gets to the end, and then it's going to create a 2048-bit key for you. I'm not kidding, right? And then you're going to get this, and then you're going to sit there and you're going to remember that 2048-bit key. It's case sensitive. No. But what you're going to do is you're going to want to set your key phrase, and this is, again, so this is, if your key phrase ever gets compromised, like let's say you had, I usually recommend if you're on a laptop or a machine that you're not always in access with, generate a new key and don't try to steal and keep your private key on a USB stick and just share it everywhere. Because that way you can always go into GitHub and everywhere else and just kill the key. This is pretty much how you kill the public-private key set. You're going to want to save the public key and save the private key. That way you're going to need the private key obviously in order to do check-ins, and the public key you're going to want to use to put on GitHub or on Bitbucket or any other source control system that you're using.
So does that encrypt the repository, or is it just
No, this is your SSH key. This is to encrypt the SSH traffic that's going between you and the server, and to authenticate that you are who you say you are when you're actually sending that payload to GitHub. You're going to want to save your files in your username .ssh path, because that's where all the tools are going to look for it by default, including Git. Because if you ever go command line and you try typing in and you're trying to authenticate to GitHub through the command line, it's going to go look here first for your public-private key. And then once you do this, it actually will, and you save this, it's actually going to associate your public-private key to Git itself, so Git knows where to find these keys. So that's why you also want to save them. And then the next thing you're going to want to do is you're going to want to log into GitHub. Obviously, you need to create an account first. You're going to create on the account settings tab, which is this weird-looking screwdriver icon. And you're going to go in and log into your account, and then on the left here, there's an SSH keys link here. And then from there, what you're going to do, I have a lot of keys so that I can kill machines off, is I had to trim it off. There's going to be an add button down here, add key. And then this is where it gets screwy when it comes to PuTTY. PuTTY's going to create all this extra stuff, and it's going to forget to put RSA-SSH at the beginning of your key. If you copy this, you're going to have to manually put those 7 characters in there, and then get rid of all this extra junk at the top and the bottom. It'll tell you that it's an invalid key if you don't, but you'll see that, and you probably can't. Shoot, that sucks. You just have to trust me. This is SSH-RSA here at the beginning of the key, and I don't know why PuTTY has a problem with this. But like I said, it won't save it. It doesn't know what the signature is if you don't tell it, because there's RSA, there's a couple other authentication providers that you can use. I just use RSA. And then, like I said, once you go and you push your changes to GitHub, the first time you do it, it's going to all these 3 dialog boxes are going to pop up. The dialog box to try to check in is going to come up. On top of that, it's going to say, hey, we don't have an SSH key loaded. So the load is going to load up, and because I already have one cached, it's actually going to pop up the text box to go and tell me to authenticate my passphrase for that key that it's then going to use to actually check in the code and push it to GitHub. Oh yeah, and make sure the PPK is the private file, and the file without the extension is the public file. If anybody ever gets a hold of PPK, just kill the key, because everybody has the keys of the castle at that point. So Git Extensions, when Git Extensions loads for the first time and you're getting ready to write some code, it's going to come up with this blank window. And what we're going to do is we're going to go through the steps in order to actually create a new repository from scratch. And you have the ability to open and create a repository. Right here is create new repository link. So when you create a new repository, all you have to do is choose the folder that you want to create it in and just hit create, and it's going to give you a message box that says that I created a .git folder inside that and initialized it to a new working folder for repo. And then from there, what a git ignore file is pretty much like an SVN. When you go and you right click on the folder and you tell it to start excluding things like .suo files and bin and objs. This is the Git equivalent of that pattern. So by default, there's a huge list of folders and file structures that you do not want in Git. So all you have to do is click on this add default Git ignore file, and it's going to add all these different things to ignore by default. You hit save, and then what it's going to do from there is it's going to save your .git ignore file, and then what you're going to do to actually commit the file. So in Git, the difference between Git and SVN is there's what's called a staging area. So you can actually put files into a staging area and never commit them. So the equivalent to that would be a shelf set. So what you have to be really careful with is if you stage your files, which means that you put your files down in here, and then you made another change to the same file again, and if you go and you hit refresh, it's going to show the file up here and it's going to show the file down here. It thinks that you want that to be two different commits. So if you actually still want that second change to be part of the first commit, you're going to want to unstage your files, put them back up at the top. It will be smart enough to actually merge that second change in with that file because you haven't committed it yet, and then put it back in the staging area, create your commit message, and go on with your day. A lot of time, and we've all had this problem, I don't know why Visual Studio, when it adds new files, it doesn't save the stupid project file. So you go, you add 15 new files, or you write an auto-generator, you're like, oh, hey, I got 15 new files, you commit it. Oh, look, it doesn't build. Yeah, it's because the CS project file didn't save. So then you go back and you hit the save button in Visual Studio, and then, oh, look, it wants to save my CS project file. I'm not going over that today, but if you wanted to fix that in Git, you can actually manipulate an existing commit and add it. I usually just get frustrated and add it and go, look at that, I forgot the CS project file, fix the build. But if you were to catch that before you physically were to commit it, you could then unstage the files, hit save, the CS project file would show up, you'd pull them back down, your commit message would still be there, you hit commit, you save it, and everything's good to go. So again, in this case, I'm pushing it down to the commit window, you type in the message, and then you click on commit, everything goes away. What's different with Git extensions than GitHub for Windows removes this complexity from here. So in Git extensions, the only way for you to push a repo to GitHub is you physically have to go and create the empty repo in GitHub first before you can push it. Where Git for Windows actually will use their API and actually go and create an empty repo for you behind the scenes when you click on the sync button, which I'll show you in a couple minutes. And it goes through and fixes these next 4 steps that are going to have to happen here. So again, what you want to do is, so you've created your offline repository, you're like, cool, I've been working on it for 6 months at home, somehow I never lost anything, I now want to put it on GitHub, right? And you can do this with any master. You know, if you want to add, put it on GitHub, you want to put it on Bitbucket, and somehow you want to put it on TFS, all you have to do is add more remotes. So it's not like you can say, oh, darn it, I didn't go to GitHub first and create a repo. Now I'm screwed. I'm going to make all these check-ins, and I'm going to lose my history. You never lose anything in Git. It's just extra steps.
So are you going to have a repository for every project, or one repository that you'll put all your projects in?
I have a repository per project. But I do have one folder on my hard drive called dump, you know, which is pretty much like all these command line tools that I don't really care about, like where you have a root and you have like these 90 things under it. I just check it all into that because it's never going to be open source and it's little tools that I've written, right? Yeah. But you can actually cherry pick the files out for that folder into a whole new repo with your history and then check it in as a whole new repo. Pretty much what you're doing is you're replaying the history. And you can do that with HG also. I've done that. So if you need to remove history from something, you can actually replay the entire repo into a new repo and remove things like if they never happened. It's like the mob. So you go to GitHub, and then to create a new repo, you would click on this button right here, and then what's going to happen is this window is going to come up. I have multiple accounts because GitHub has these concepts called organizations, and they also have a private account. So this is my private account, Joe Feeser, but if there was a Logical Advantage organization, I could determine that I want to either create this repo under Logical Advantage, I want to create it under my own account. So they fixed the problem of having 16,000 logins in order to do something on GitHub. You have one login, multiple identity sets once you log in, and then everything's based on that identity set. And permissions per identity set can be different too, which is really cool. So you create your username, you give it a repository name, the only thing it's checking is whether or not you've actually created that repository already in the past. It's going to, only time it's ever going to fail is if you either have illegal characters or you've already created that repository. If you had the ability to create private repos, you could check on this private button. I'm not even really sure why they give you the ability to click on private when I don't have an account. Be careful creating the README file if you already have a repo that you're going to sync with, because you're going to get a merge conflict right off the bat. Because your repos, the origin is going to be ahead of your local copy, and you have to, I mean, you can fix it. It's just extra steps. And then you click on the Create Repository button, and then magically this screen comes up and says, hey, we're going to assume that you're on the command line, and we're going to tell you all the different Git commands that you need to run in order to get this thing working on your local machine, which is cool. You don't need any of that. What we're going to do is we're going to do it in the UI. We're going to go back, and we're going to go back to remotes. We're going to go and we're going to click on Manage Remote Repositories. We're going to take the URL from this screen right here. You're going to copy this repo name, and then inside the IDE, you're going to go and you're going to create a new remote. I recommend calling it origin all lowercase, because Git is case sensitive, and most people refer to as their master as origin. So whenever you see Scott Goo do a demo and he does, you know, git push origin master, or git push master origin, he's saying push the master branch to origin. Origin is an alias to a remote, and it is case sensitive. So if you do that, it just magically works, and the demo seems much happier. So you're going to give it a name, you're going to give the URL, and again, this doesn't have to be SSH. If you want to use HTTPS, you just have to go back in your GitHub settings here and change this to HTTP, and then this will change to an HTTP address. You don't have to, you know, so again, if you didn't want to set up all this putty stuff, it just works. And then the first thing you need to do in order to push is you're going to have to pull the repo before you push it. So you're going to, in the ID, you're going to use the little down arrow key for pull. Oops. So there's a push and a pull icon here. Obviously, the down arrow is pull, the up arrow key is push. So you're going to click on this down arrow key to pull. It's going to say, well, what do you want to pull from? And you're going to pull from origin, and you're going to pull the master branch, and you want to check this bottom checkbox, which is do not merge, but just fetch. So I never went over this concept. So Git has two concepts. There's what's called a pull, and there's called a fetch. So a fetch goes and says, this is all the potential things that you can merge or pull, but it only gets a copy of the files. It actually doesn't apply it to anything. So pulling is actually a fetch and a merge behind the scenes, where a fetch is just a fetch. So literally when you do a git pull, it's literally doing git fetch and then git merge behind the scenes for you. It's running both commands for you. And then once you push, you know, I mean, once you pull, then what you're going to do is you're going to want to do a push. Unfortunately, you can't read this, but I'm pushing to origin, and I'm taking my master and pushing it to master. Again, there is no limits to what you can do with Git. You can literally take your branch on your local machine called development and push it to master on the server, and it will just magically figure it out as long as there's no merge conflicts. The name of your local machine, of the branch in your local machine, doesn't have to match the server. It's advised, but if you want to name your stuff after ships in Star Wars, and you know, and you got nothing better to do, then you can do that. You might piss off some people on your team, but there's two things it's going to ask you to do next. Is it's going to ask you, it's going to inform you that the branch that you're about to push to origin does not exist. Are you sure you want to do that? And then it's going to ask, do you actually want to push? Do you want to create what's called a tracking branch? And again, tracking branches, so what a tracking branch is pretty much saying, I actually will probably make changes to this on my local machine later, so make a local branch and call it whatever you want to call it. So again, you can when you fetch, you have the origins, the remotes, source code in your machine. What you're physically doing when you do a pull is you're making a copy of the origins code that's on your machine, and you're actually applying it to your change set in local. It's almost like it's two sets of code inside the repository. Because again, all it is pointers to pointers. I don't know, somebody who actually knows a lot of math wrote this. It's the guy who wrote the Linux kernel. But there's no chance in hell I want to write this. So again, you can do all this on the command line. So I'm going to show you how easy it is to create a branch in Git Extensions. So under commands, all you have to do is choose create branch. And I don't know why, to add more confusion to the fire, there's checkout branch and there's create branch. During the creating of the branch, we're going to create it and we're going to check it out. So what the IDE is going to do is it's actually going to do two steps for you. It's going to do a git branch name, and then git checkout branch name. So at the command line, if you literally type in git bob, git branch bob, it's going to actually it's going to change you to the branch called Bob, or it's going to create a branch called Bob for you. Then if you do git checkout Bob, it will literally change the pointer to this new concept called Bob, even if it never existed yet, assuming that you're going to make changes on that branch. So you go in, you're going to give it a name of the branch, and you're going to create branch, and there's a checkbox here that says checkout after create, and it's literally going to do a checkout. It's going to create it and it's going to check it out. And then in the IDE, you're going to see at this time, you're going to see both the master and the new hotfix branch are both going to show up in here. So what Git Extensions is showing you is these bold markers here are where your code in your hard drive is in perspective to everything else in the project. Being that this is the initial check-in, it's not as obvious, but as one branch moves forward in time and one stays behind, the one marker will stay down here and the other one's going to keep popping up. And you can see, how many ahead or how many behind things are based on how these little tags move up and down the IDE over time. So what I'm going to do is I'm going to make a change to the README file, and I'm going to change the version, and I'm going to add that the branch that it's from is actually in a branch called hotfix, and I'm going to commit that file. I'm going to check it in, and now you see that master is down here, and this is no longer current. So what happens is the bold turns to a non-bold text, which is saying, look, this guy is behind everything else. Only items that are bold are actually at the most current. So hotfix is ahead of master. And then what we're going to do is we're going to change back to the master branch and actually apply the change that we just made in hotfix back to master. So what we're doing behind the scenes is you have master, you created a text file, and you created a bunch of code, and you said, this is my deployment. And then all of a sudden you made a hotfix. So what you did is you changed to the hotfix, you created a branch called hotfix. You modified your CS files to apply that hotfix. Now your project manager said, look, I want to apply those changes that were done in the hotfix to master because we're about to do a deployment. So at that point, what we're doing here is we're doing a merge, and we're merging the changes from hotfix back into master. We're applying them over the code. We're taking the combined code together, and that's going to be a new change set. And then that's going to be both, what's current in master and everything in hotfix. Okay. So again, the hotfix right now is ahead of master. We've changed to master. You see that we're bold. So in the current branch, master is now ahead of everything else. This seems weird the way it's wording this, but what you're going to do is you're going to right-click on the hotfix branch. You're going to go down and say merge into current branch, and you're going to be like, well, why am I merging hotfix into hotfix? And this seems weird. What this is really telling you behind the scenes is I want to merge the local branch called hotfix into master. What'll happen is if you have remotes and you have other origins in your source code, there might be 15 different options here to ask you where you want to pull it from. I know. So I didn't have time to set up a situation like this, but if I were to go and make a change on remote and do a fetch, and it's on my local machine, I could literally, without ever getting latest, pulling it into, I could literally say take remote hotfix and apply it to local master. Because again, it's a pointer to a change set that exists somewhere in La La Land. It's going to bring you up this checkbox again and ask you, are you sure this is what you're trying to merge with? You're trying to go into master from where? And again, so if you chose the wrong thing before, you can choose it again. Now, I don't know how TFS or SVN works when it comes to merging, but there's two different ways that you can merge in Git. And there's what's called fast forwarding, which is pretty much take all the things that I did in that branch and take them and replay them one by one in line, like they never happened in the branch. So in other words, just make a copy and just apply them. So in other words, just take the branch and literally just flatten the branch right into master. And that's called fast forwarding. The other thing was the option I use, which is the second option, which is always create a merge check-in. So what it's doing is saying, look, I want you to create a diff of everything that's in my branch compared to everything that's in master and create a check-in, like there was a real legitimate check-in that somebody actually went on the machine and typed in and created the master check-in and apply that as a change to the actual source. Some people like to have what's called temporary work, low, very short-living branches. So if you created a local branch, and again, the scenario is I'm creating something that's a breaking change, I still want to be able to pull from master because I'm working with Mark on a problem, and I don't want to pollute it until the end of the day. I might want to fast forward all those changes into master because I've only done it local. I've never pushed that branch to origin. It's only exists on my local. I might want to fast forward it in at the end of the day. And then at that point what happens is effectively the branch disappears like it never happened. So what you can see here is, so you started down here, you branched off, you created your hotfix, and then you pulled your change from hotfix back into master. And then if you look at the check-in down here, you'll see that what I did is I removed the master branch text, version 1.0.0, and replaced it with 1.0.1 on hotfix branch. So this is the diff window. I removed this, I added this. Okay?
Is there a way to see beyond compared diff down there?
Yes. At any time, you can literally right-click on this file and say, or I think the hot command is F3, and it will literally show you the change in beyond compare. And if you have beyond compare 3 Pro, if it was a merge that actually had merge conflicts, it will actually show you the 3 windows and show you that this is what I had, this is the base, this is the remote. And I go over that later on what these terms mean because base and remote to me, I would have picked a different word, but it's not my system. So again, you see here, hotfix, bold, no origin, master, bold, no origin. When I push it back and push the changes back to origin, you see now that I have master and I have origin master. So that means that this pointer on GitHub has been updated to this particular change set. I screwed up when I was creating these slides and it was too late to go back and fix it, but if I would have done a multiple branch push, hotfix would have gone to GitHub as a remote branch like it actually existed, but in this case what I did is I created the net effect of what happened here is I had a local branch called hotfix and I have a local and a remote branch called master. But if I would have done a multiple branch check-in and push to GitHub, I actually could have tracked both of those branches on GitHub. So the equivalent of git clone, and I'll show you, it's actually easier to do this from the command line. In order to set up Git extensions to do cloning, what you have to do is you have to set up an OAuth certificate with GitHub. I know. They really want you to use HTTP. So you go under plugins and you choose GitHub. I don't know why plugins are GitHub. What's going to happen is it's going to pop up an Internet Explorer window. It's going to warn you that it's not the right version and they no longer support it, but log in anyway. And then what's going to happen is it's going to create an OAuth ticket, and then it's going to download the OAuth ticket, and it's going to store it inside the tool. And then that way you're going to be able to go to the actual GitHub tab. And then from the GitHub tab, you're going to say fork clone repository. From the fork clone repository, because now you've authenticated, it's actually going to go and download all your repositories that you have from the server. And what's nice here is it's going to tell you, is what you're trying to pull down a fork of somebody else's code? So I've somehow became the owner of the MVC, MSpec testing tools for auto mocking in the MVC framework. So I'm also the NuGet package owner because I volunteered myself. But you know, all my repos set up here. It tells you how many forks there are globally in the entire system. You click on the one you want. If you wanted to change the folder, you can change the folder. You can even change the current directory name if you want, and then you hit clone, and it magically pulls everything down. But truthfully, it is so much easier to just drop to the command line, go to the folder you want, and say git clone, and then take the actual Git repository name, do it. It's going to pull it all down in about 4 seconds. And then you're just going to be magically done. So literally those last 6 steps can be done in one if you're willing to go to the command line. I actually had to go and research how to even do a Git clone in Git Extensions. I've never done it. Every single time I've ever done a clone has always been in the command line. So what did GitHub do? They decided we're going to make it very simple, and we're going to tell you what features that you have available to yourself. So you go to windows.github.com, and there's this really awesome blue screen, and then you click on this download 1.0, and it's going to download one of those .NET 2.0 install from web things. What do you call that thing? Yeah, whatever that thing's called. And then it's going to, it's going to do this, this thing. Whatever this thing is called, the thing we all tried back in 2005 when it came out, was it's going to solve all of our deployment problems, and maybe one of us actually got it to work. After that, it's just going to magically load, and it's going to stay white, and it's going to say, please load, please wait while we go and troll your hard drive for repositories that already exist, which is kind of hot. And then what's going to happen is this is going to be your main screen. This is really one of your only screens. I filtered it down because I had just way too many projects here, but there's a text box here. Whatever you type in, it's a starts with, it's not a contains filter. So hopefully you know what your repository is. And then behind, it's very hard to see, even if you have the client locally and it's installed in full size mode. There's actually a little graph here that shows your commit history over time per week. So there's 52 little graphs here that show the commit history of the project over time. So you can say, hey, I want to get involved in that. I don't know if it's doing real-time calls to get the update from the server, or if this is only your local copy, but this is local repositories. And what's really cool, this is why you should always keep a README file up to date. Whenever you click on any of the projects here, it automatically shows you the README file. So if you want to know what's going on with the project, it will automatically, whenever you click and you clicked here, it would actually update the README file on the right in real time as you click, which is kind of cool. So once you click on that, it's going to bring you to this window. This is the equivalent of the window I was showing you before for Git Extensions, which is your check-in history. The difference is, instead of it being on the right, these are your check-ins. All here is your check-ins. And then for any check-in that you've clicked on the left is all the files that were associated to that particular check-in. Totally opposite from the other IDE. The difference here also is it's very hard to see where you are. So there's this tiny little thing that says you're in master. There's no real way to visualize. And I'll show you how the hack to get around visualization of the tree in a couple slides here. But what's kind of cool is, if anybody's ever used GitHub, is if you click on these little tooltips here, it automatically will expand and show you the diff per file. So as you click on this, it'll show you what's changed in the files. You can go and see what was done on the check-in, and as you click on all these, I'm pretty sure if the file is in both, it keeps the diff open, which is kind of cool. There is no Beyond Compare support in GitHub for Windows. I know there's a way to set it up through the command line. I couldn't get it working. So there's no right-click, there's no F3, show it in Beyond Compare. So the reason why I went through all before and said seems like a lot of work to set this stuff up, if you've done anything power-wise, which is like you're more than one person on a project, This product is really cool if you want to go and get a repo, check it out. You don't want to putz around. You want to make one small change and upload it, and you never think you're ever going to do open source ever again. GitHub for Windows is your way to go. If you're going to actually get serious about this and you need the power and you want Beyond Compare and you just want it to right click and all be integrated in the same tool, you're really going to want Git Extensions. I mean, I send Beyond Compare more money than I need to make sure I'm licensed enough, because I have it's just so many copies in so many places. Because I need the Pro Edition, because you need the three-way merge.
Three-way merge is awesome.
Yeah, three-way merge is the bomb. That was the best $50 upgrade I ever did in my life. Yeah. Branching is a very simplified model. You click on the little master icon here. It shows you all the branches that exist in the project. If you wanted to be able to manage and do merging, you click on this little manage link. It's not straightforward. I don't know if anybody just doesn't do merging in this tool. I don't know. So you click on manage, and then it brings you to this tool, and you're like, what is this, right? So this is your current branch. These are your other branches, and literally to do a merge, you literally drag your branches down here, and you say, I want to merge from here to here. It re-repeats exactly what's here, and then you click on merge. So they make merging all drag and drop. They get rid of all that right click. Why is it asking me about origin and master? But I don't know what happens when, I don't know if you lose that ability. I don't know. Again, I did this to give you a comparison. Oops. So I couldn't figure out how to do branch visualization, so guess what? Time to drop to the command line and run a very small command called Git Log Graph, pretty format with about 6,000 other ASCII characters. And this is actually the branching that you can't visualize in GitHub for Windows. You know, this is all the check-ins that I'm doing. You can see over time I'm merging everything down into the master. You can see there was a lot of activity on doing a bunch of, you know, hashing of things out in different branches, and then eventually they clear out. Maybe it's in the tool and I couldn't find it. I don't know, but this is how I had to visualize. And I've actually gone over to Git Extensions and done visualization there. Like if you still want to use the tool, you can use both. If you really think that you know, GitHub for Windows is helping you. I mean, it is really cool for auto detecting and allowing you. There's no dialog boxes, right? So the whole world of we're moving away from you know, the whole Windows. If you're a Windows guy, you obviously are a loser because you have these pop-ups and dialogues with 6,000 buttons, and it should work more like a Mac, right? So they have it where there's not one dialog box in this entire app. When there's a change, a pending change, the uncommitted changes becomes yellow to tell you that something's happening. All your files show up over here that need to be changed. You can check and uncheck them. You literally give it a description, you hit commit, and you move on with your day. And then it tells you right here there's unsynced commits, right? So you did a change. It's saying, hey, these particular things are not on the server yet. So here they are. What do you want to do with them, right? And what's really cool is all you have to do is click on the sync button. You don't have to know about pushes and pulls. You don't have to worry about the terminology and if it's an origin or a local branch. You click on sync, it just does all the black magic for you. You don't have to care why it works. It just magically works, unless there's a merge conflict, I guess. Creating a new repository is very simple. There's an add button up here. You just click on add. You get this sliding window thing that's not a dialog. You give it a name, you give it a location, you tell it if you want to automatically sync with GitHub, you give it your account name, and you hit go. And again, you don't have to mess around with it. All those other steps we had to do in Git Extensions, depending on the order that our workflow is. If we start, you know, on GitHub first or after, they make all that work for you. So really, if you don't want to putz around with the other one, getting it all synced up, maybe you want to go in here, create it, and then close the app. So again, same view I was showing you before. I created a repo on GitHub. It has the same blank, hey, what do you want to do to start? It didn't know I use GitHub for Windows, so it tells me how to dump to the command line to do it again. I don't know if this is because I already had an active filter going on, but it lost. When I created the new repo, it didn't automatically open it, so I had to go and find it in the filter and then click on it to make it active, and that might be an operator issue. Once you do that, it's going to ask you to add the git ignore and the git attributes information so that you can, you know, same as the other application. And then you're going to want to, you know, make the changes and commit them. And then what's interesting about the first time you push a repo, for some reason they changed the sync button to publish. Just keep in mind, publish and sync in the eyes of GitHub for Windows seems to be the same thing. Because once you publish it the first time, the button changes to sync. I think they're just trying to tell you that it has never been pushed to origin, so they're trying to help you. And then you can verify that your changes actually made up in GitHub. So, you can make changes, same as you did in the other application. Make changes to the README file, commit them, hit the save button. And then creating branches in GitHub for Windows is pretty simple. You go to branches, you type in a name, and you say create branch hotfix, just like we did in the other app. Then I'm going to go and I'm going to make the changes to say version 1.01, hotfix branch, commit the changes. But again, there's no visualization, right? So you just have to know where you're at. So then what I did is I went and I clicked on the merge button. Here's my hotfix branch. Here's my master branch. But what's interesting about GitHub for Windows is I don't have to change back to master. I literally dragged hotfix down here. I dragged master here. It says, hey, your output's going to end up in master. I hit merge, and then magically it just worked. So this goes to some of the other questions that people are saying about file history and beyond compare. So what's really, really cool, has anybody ever wanted to know what the cumulative diff is for a file over 45 check-ins instead of just the last check-in? All you have to do is click on the first one, which is your baseline, and your second one, which is the one that you want to compare it to, and literally the cumulative diff is going to show up in the bottom, and literally all the diffs that have ever occurred between those two is going to show up here as the cumulative diff. And you can do it in reverse. Do you ever want to know what the unchanged on files to get it back to where it was? Click on your newest file first and click on the old file next. It'll actually show you what to erase to actually put it back to the original state, right? So that's kind of cool. That's not obvious by looking at the IDE. So inside that tool, you can right-click and say File History on any single file. And what it's going to do is going to bring you up the File History dialog box, because it's a Windows app, and it's going to show you every single time that file changed. It's going to show you in the View tab, it's going to show you what the file is. You can click on the Diff tab, or you can click on the Blame tab. Blame in Git takes about 1/8 of a second to come up. I think in SVN sometimes it tells you this may take a while. But literally, at any time, it shows you line by line and check-in by check-in what's been changed in the file. And as you mouse over, it'll actually show you the commit information about the user, who it was, the time, and the actual message that was used at the time you mouse over. So you can literally, in a line by line, see the actual diff. And then if you wanted to know what the change was before that, if you literally click on this or click over here, it will literally change your pointer in the actual file history window at the top to the actual point in which that change occurred. And then it'll show you in perspective to what happened before that. So that's kind of cool. Merge conflicts. So I said we're going to go through the rest of this real quick. Eventually you're going to get the little red X of death, and you're going to probably roll it back the first time because it's going to be easier. But it's rare to get merge I mean, you really have to have a lot of active stuff going on in order to get a merge conflict, or a lot of people in the same file at the same time, changing the same files. But it's going to ask you, there's a merge conflict. Do you want to fix the conflict now? What's nice about this, you can roll back at any time. So if you get all the way down the line and you're like, man, I totally hosed up this merge, just hit, literally this yes, no is going to ask you 4 more times before you get done. And at any time, you can just undo it and just start over. Because there's times where you're just tired, bad things happen. But if you hit yes, what's going to happen is it's going to bring up this dialog box, show you every single file that's in a merge conflict. And our favorite button here, this is called the Start Beyond Compare. It's really called the Start Merge tool. You can run a merge tool per file. There are ways to go and actually go look at the staging area. And that's what the Open In button is. So you can actually open it up and actually load up the staging area and go and actually modify the file by hand. So if you just know that you just need to replace the file because there's just too much, you can literally just go in and save the file and just say, yes, I've resolved the merge conflict. I'm not really sure why it does this, but when you start the merge tool, it actually jumps to the command line, says, are you sure you want to use Beyond Compare? Just hit enter. And then merge Beyond Compare is going to come up. In the new version, I had 1.04. In the old version, I had 1. Here's the baseline. So in other words, here's the oldest change between the two branches, 1.02. In hotfix, I had 1.03. In master, I had 1.04. What will happen in Beyond Compare is it's going to show you this little red arrow. It says these are the lines that have merge conflicts. You can do a global change and say, I want to pick the blue side or the pink side. The blue side, I think, is the left, and the pink side is the right. Or you can go line by line, and it will show you this is what it was on one side, this is what it is on the other side, this is what I think it is, but then you can override it. So here I actually took one side on one line and one side on the other line because I wanted even though this is an older change, I wanted the hotfix line, but I wanted the version from the current branch that I'm in. And you can do that with Git. And then once you resolve, you could say the results have been merged. Are you sure you want to commit? And at this point, you could still say no. Now, you're going to lose all the work you just did because it's going to literally roll back anything you attempted to do during the merge. But you hit yes. It's going to bring this up. It's going to put your changes in the staging window. And then once you do the change, for some reason, it always keeps the original file in case you want to go back and modify it. What I do is I just add it to the git ignore file so they never come up again. I commit the git ignore and I commit the file. My changes have been made, and then that part just particularly works. So for syncing branches, this is the same concept. So normally what I like to do is I like to, you have your master branch, then everybody's in another branch, and then as the day goes on, let's say that you're over here and you want to merge changes in, so you want to sync them back into your branch. So you want to keep pulling from master into hotfix, keep pulling. Because you don't want to be the build breaker guy that says, hey, I got my stuff in, man, I'm going home, and just push it back to master and just push it. So what this gives you the ability to do is you stay in your hotfix branch, you pull the master back in, you verify it still works, and only at that point do you push it back. So you have a lot of lines going back and forth. You're pulling in the hotfix, you're pulling in the master. So you'll see a lot of this weavy pattern going back and forth as you're going through your day if you're working in branches, especially branch per feature set. So what I'm doing is right now is I'm in the hotfix branch. I want to take the conflict that we just dealt with and the merge that just happened. I want to pull all that stuff back into hotfix. And you would think now I'm going to get another merge conflict, right? Because I just putzed around with this in one direction. I'm probably going to have the merge conflict in the other direction. You're not going to because it's already done the resolution. And it already knows it's done the resolution. It already knows that the files that you're bringing it back into, those change sets already are applied to the actual merge. So when you pull them back, you literally say, I'm in hotfix, I want to pull it back from master, do it as a merge commit, and literally, it doesn't even tell you jack, it just does it. Cherry picking. So cherry picking is also one of those things I had to look up to explain to people because cherry picking is one of those things, did you ever have one of those things where somebody checked in a bunch of files at one time, but it's somewhere else, and you can't just, you want what those changes were, but you can't just X copy the files over because you have 15 other changes in the CS proj file. So you want the changes that occurred at a particular point in time, thanks, but you can't just pull them in because you already have 6 other changes to your CS proj file. You've already changed a no reference exception in one of your files. So, but you do want what happened at that change set. You literally can cherry pick a change set from another branch or anywhere else in the history and apply it to your current code set. And that concept is called cherry picking. So that's the presentation.
Cool.
Do you guys have any questions? I'm sorry I ran over.
Yeah, thanks, man.
Yeah.